In Module 3, Lesson 10, we're going to look at angle problems and solving equations. We're starting off with a table of four different drawings. And you should observe first the drawings and the different ways that angles might be notated in the table. Then we're just going to review a few facts about angles. First of all, adjacent angles are when two angles share a common side. In this case, the common side is ray AC. And so these two angles, BAC and CAD, have a common side of AC. So they are adjacent angles. Angles A and B are adjacent angles. We can name them that way because they have separate notations. We also can name them BAC and angle CAD. This is the angle symbol. Vertical angles, the next type of angle we have, are very interesting. Two angles are vertical angles, or vertically opposite, that's what it means, if their sides form two pairs of opposite rays. And A is equal to B. Angle A, which we've labeled here, is equal to the measure of angle B. So in vertical angles, opposite angles are congruent. Another way to write that is angle DCF. DCF is equal to the measure of angle GCE. Angles on a line. And please note that this is a straight line. The sum of the measures of two angles that share a ray that are forming a line that is 180 degrees. Well, that's rather confusing. But when angles join together to create a straight line, like we have in this figure, their total measure is 180 degrees because a straight line measures 180 degrees. So no matter where you see it, as a matter of fact, look up here in our vertical angles. There's a straight line, so these two angles would equal 180. And here's a straight line here, so these two angles would equal 180. So in this diagram, we have three angles that make up our 180 degrees. In the case of the way they are labeling this particular situation, I think would be best to edit their work a little bit. A plus B plus C equals 180. And that would mean that, wow, all their labeling is off here, sorry. Angle BAC plus angle CAD plus angle DAE equals 180. sum of those three together. Now we could have named them, for example, BAD plus DAE, and that is 180 degrees. Just because there is a ray splitting them apart doesn't mean that this is not an angle. And then finally we have angles at a point. This right here. And in this situation, the three angles are combining to make what we would consider a full circle. And a circle measures 360 degrees. So the measure of all angles formed by three or more rays with the same vertex is 360 degrees. But that is simply because it creates a full circle. So in this case, the measure of angle A plus B plus C equals 360 degrees. And they've notated it correctly as BAC, CAD, and DAB. So we have a drawing in our opening exercise, and the angles that are vertical are AEC and BED. You can find vertical lines by looking vertical angles by looking for straight lines that intersect. And if you're not sure, take a straight edge piece of paper and lay it on the line. And if it lines up perfectly, it's a straight line. We also have vertical angles in CEB, CEB, and DEA. Those are also vertical lines. And we know that because we see the straight lines, vertical angles, because we see the straight lines creating them. The adjacent angles in our figure are AEC and CEF, but also CEF and FEB, BED and DEG, and GEA and AEC. So there are a number of combinations. Angles on a line, we have BED and DEG and GEA. These three create a line, which is 180 degrees. We also have AEC, CEF, and FEB. That is also 180 degrees, or a straight line. But there are other combinations. Anytime you have a straight line and something else cutting through it, you have the opportunity to have angles on the line. And then finally, the angles at a point that we have would be all of them named together: AEC, CEF, FEB, BED, DEG, and GEA. And altogether, they equal 180 degrees. So in example 1, we're asked to estimate the measurement of x. The angle relationship between these two angles is, first of all, that they are adjacent, because they are sharing ray AC, but they also form a straight line. So when we're asked to write an equation for the angle relationship, what we need to do is x plus 132 equals 180. And then it would follow that x X would be 48, because 180 minus 132 is 48. So X is 48 degrees. Exercise 1. In a complete sentence, describe the angle relationship in the diagram. Well, we do have there are adjacent angles which form a straight line. So when we are asked to find the measurements of BAC and DAE, we know that the three angles together add up to 180 degrees. We know that BAC is 3x and DAE is 2x, but we also know that CAD is 90 degrees because they have marked it as a right angle. So we would write our equation 3x plus 2x plus 90 equals 180 degrees. And then to solve our equation, we would combine like terms, which will give us 5x plus 90 equals 180. And then we can subtract 90 from both sides, which will give us 90 degrees. And finally, we would divide 90 by x, or by 5. Which will give us 18. So x is equal to 18, but that doesn't give us the measurements of the angles. That just tells us what x is. 3x then would be 3 times 18, which is 54. And 2x is 18 times 2, which is 36. To check our work, we want to make sure that 54 plus 36 plus 90 equals 180. And it does. In example 2, they ask us in a complete sentence to describe the angle relationship in this diagram. And these angles are vertical angles. Which means that opposite angles are the same, and that term is congruent. So we'll write an equation for the angle relationship and solve for x and y. First of all, we could say 144 plus x equals 180, because this is a straight line. 144 plus x, those two angles create a straight line. And then solving for x in this situation will tell us that x is equal to 36 and then now that we know that x is 36 and we're looking for y, we could say that y y plus 36 equals 180. X plus y equals 180. We know that x is 36, so y plus 36 is 180. And then that simply means that y equals 144. Exercise 2, the relationship of the angles in this diagram is that they form a circle. Which is 360 degrees. And certainly there are some other relationships here. I see some straight lines. There's one here, there's one here. So there are adjacent angles and angles that add up to 180. We're asked to write an equation for the angle relationship shown in the figure and solve for x. Well, since angles JEK and MEL are not labeled, and we need to solve for x, I'm going to elect that we solve as vertical angles rather than as the full circle. So our equation then would be 3x plus 16 equals 85, since these two angles are vertical and vertical angles are congruent. Then in our solution, we find that 3x is equal to 69. And if we divide by 3, we get 23. So the value of x is 23. But this angle here, which is 3 times x, would be 69. Example 3, the angle relationships in this diagram do add up to 360. They are circular. Which is 360 degrees. So our equation then would be x plus 135 plus 90 degrees, and we know that because of the marking inside the right angle, equals 360 degrees. Then we would combine like terms, x plus 225 equals 360. So x equals 135 degrees. Exercise 3, the angle relationships in the diagram. Well, we don't have any straight lines. We do have a circular relationship. So that is going to be our choice. So finding the measurement of GAH is going to require us to add these others together. 103 plus 59 plus x plus 1 plus 167 equals 360 degrees. Now I can put x plus 1 in parentheses the same way it is in the diagram, but because everything is addition, it doesn't really matter. We do need to combine like terms. And when we add all of the numbers together, we get 330 plus x equals 360, which means that x equals 30, and the measurement of GAH is x plus 1, which is 31 degrees. Finally, example 4. Two lines intersect in this figure. The ratio of the measurements of the obtuse angle to the acute angle in any adjacent angle pair is 2 to 1 in this particular diagram. So in a complete sentence, we're going to describe the angle relationships in the diagram. They are vertical angles and opposite angles are congruent. Adjacent angles add to 180 degrees. So when we are trying to solve, we would say 2x plus x equals 180 degrees because it is a straight line. Combining like terms, 3x is equal to 180 degrees, and so x is equal to 60 degrees, which means that our smaller angle is 60 and our larger angle is 120 degrees. And exercise 4 says that the ratio of GFH to EFH is 2 to 3, 2x to 3x. These angles are adjacent and they add to 90 degrees, which we know because of the marking. So then we would say 2x plus 3x equals 90 degrees. Combining like terms, that gives us 5x is equal to 90 degrees. And so x is equal to 18, which means 2x is 36 and 3x is 54. Review the vocabulary. Make sure you understand what you are looking at. And then complete the problem set.